Alright, so this is for Algebra 1. Your Chapter 6 summative assessment is going to be on Wednesday. Here's a little extended response question just to get you in the mood of thinking about it. And if you remember, this is a familiar question to you. Linda is wrapping gifts at a toy store. The gifts are boxes. Each box is a cube. Okay? So first of all, let's get a visual. Do you know what a cube is? A cube is a box that is made up of all squares. So if you make the front square, and you make the back square, and then you connect. Right, there's a cube. So it has 6 faces. 6 faces, and they are all squares. Okay, alright. So first, A, Linda writes S equals the cube root, or the third root of V, where S is the side length of a square face in the box, and V is the volume. Write this formula using rational exponents. Oh, you have a rule, okay? Here is the rule. X to the 1 over n is equal to the nth root of x. So how can we apply this to our problem? Well, we have s equals the third root, or s equals the third root of v. So we can apply it to this side by writing this as v to the 1/3 power. S equals v to the 1/3. Okay. B, it says the area of one face is a equals s squared. Use the answer from part A in this formula to write a in terms of v. So what do we have? Well, right now we have a equals s squared. That is a in terms of s. But from part 1 we have this, s equals v to the 1/3. They want us to write a in terms of v, which means get rid of the s. Well, we just did chapter 5 where we worked on substitution. So we're going to take this v to the 1/3, and we're going to put it right in here for s, because that's what s equals. So we'll have a equals v to the 1/3 raised to the 2nd power. And now we have these two exponents. And over here, little side work. The exponents we multiply together. 1/3 times 2. Make it a 2 over 1. 1/3 times 2 is 2/3. And that is the new exponent of our v. A equals v to the 2/3. This is a capital V for volume. Okay, next one here. So now it says write a formula for the surface area of a box in terms of V. And again, this might be more than you know, but I will give you a hint here. To find the surface area of a cube, you simply say 6 times A, where A is the area of one square, or area of a face. Area of a face. And again, the idea is they're all the same. So if you had the area of one face, you times it by 6 because there are 6 faces or 6 sides to this box, you'll have it. So now we have this formula, SA, surface area equals 6A, 6 times A, and we have from part B, area equals V to the 2/3. So now they want the surface area in terms of the volume. So now we're going to take this V to the 2/3 and we're going to substitute it into there to make our surface area formula 6 times V to the 2/3. And last but not least, find the surface area of a box that has a volume of 64 cubic inches. So this is telling me that V equals 64. Well, you have this surface area formula, 6 times V to the 2/3. Take 64, put it in place of V. Surface area equals 6 times 64. I'm going to put the 64 in parentheses to the 2/3. And now you have some choice here. You can work with this rational exponent, or you can use another rule. And I'm going to slide down to show you this rule. There's another rule. I'll put it right here. X to the m over nth power I'll write that better so you can see the m and n. X to the m over n equals the nth root of x to the mth power. So we can take this and do a little sidebar, and we can turn 64 to the 2/3 into the third root of 64 squared. And the way that you were taught was, is there a way to write 64 as something to the third power? And there is. 64 is 4 to the third. So what happens? Because the exponent and the index match, they cancel, and this is simply 4 squared. And 4 squared is 16. So now I take this 16, and it's going to go in place of the 64 to the 2/3. So my surface area is 6 times 16, and 6 times 16 is 96. It is area, so it's inches squared. So again, just get in the mood of how a extended response feels. Again, the surface area is a little murky, but hopefully you knew the rule of the rational exponent to the radical notation and back and forth so that you do this problem. And it'll be helpful for the summative assessment. All right, thanks for watching, and we'll see you on Wednesday.